It's a really great question about what Docker is, because it's a couple of different things. I mean, besides the company, let's talk about the technologies. Docker, for the most part, is two really important sets of things. It's an image format, which has it's a manifest for how you build the image format. So you take a Docker file and you can build images from that Docker file and share them. Docker Hub is completely genius. That ability to share images and build from them with others is fantastic. But it's also a set of tooling mostly around Linux name groups, namespaces, and C groups that allows you to run those images in Linux. And so that those two pieces of it together are what I think of when you ask what is Docker. But I'm being specific about the two pieces because you can actually separate them. You can have Docker images, as we've seen with Rocket, that you don't have to run inside the Docker daemon, and that the importance of the Docker image, I think, is what makes it a really great way for us to build things on our laptops that we can then ship to production in a way that gives a lot more predictability about how it will operate than we've been getting with other mechanisms. And so, can I ask you, John, within this group, help me understand, is this a group that's mostly focused on operations or mostly focused on front end, or yeah?
We've really gotten a diversity. If you have a preference, do you really feel an affinity for infrastructure, IaaS type stuff? Do you are you more developer focused? I think Casey would be happy to tailor his presentation here to your particular interests. So I'd love to get feedback from you guys as we go along.
Indeed, absolutely. And you know, the reason I asked is not actually so much because it is substantially different. What I like about Docker images and the way it can help us is that it actually helps, I think, bring development and operations much closer together. And so that's that particular that opportunity with Docker images, especially the way that we can run them on our laptops and expect them to work basically the same way in more substantially similar ways on our laptop to what they will in production. That's fantastic, and that's an age-old problem. It works on my machine, of course, and I think in a significant way, that's one of the best problems that Docker solves. The challenge, of course, is what happens as you try to move from your laptop. And let me actually share a screen here, if that's okay.
Yes, go ahead. Go ahead.
Yeah. So, I think my screen is now visible here.
Yep.
Fantastic. Now, so I'm on my laptop right now, but I'm going to SSH into an online virtual machine that I created in the cloud. And so I'm SSHing in there. And you can see there's some things I could update, but heck with that. And I've already installed Docker on here. And I got to admit, I'm using old Docker prior to the split with Moby. But let me make a shorter, because I haven't done much to modify this. Let me just make a shorter prompt. There we go. That'll fit on screen a little bit better. So if I do Docker info here, you can see that I'm running on this VM. And now if I do a Docker run, -d, -p, 80:80, Nginx, this is going to start Nginx. Docker daemon. Here we go. Well, perhaps Perhaps I've messed this up, and the answer is I've already got a thing up. So Docker PS minus A. So this is Docker operations to a certain degree. Docker RM minus F. PS minus A minus Q. So what I'm going to do quickly is delete a bunch of Docker images that we're running, so I can start from scratch, which is what we just did. And so I'm going to do Docker run minus daemon, and I think I'm going to bet a lot of people know in this room what these different command line options are. I'm just going to share them so that everybody can feel included here. So Docker run minus D is, depending on who you ask, either daemon or detached mode. Minus P, and I'm going to use 80:80 to open up some ports. And then I'm going to give it the image name, Nginx. And so now I've started Nginx. And the great thing is, if I go to my, my instance details here, I can get the IP number from my instance and go there, and bam, we've got Nginx. Now, just so you know, I could also get that from here, looking at the network interfaces in here, and so I can see that that same IP address is here. And so obviously you can take any Docker image and then run it in the cloud simply by starting up on a virtual machine in the cloud. But I bet this audience has already done enough to know this kind of problem which is actually what we saw at the start of this, which is when I try to start another copy of this, it says, hey, failed programming external connectivity endpoint, port is already allocated. And so the problem is, within Docker, you can have as many containers as you have memory for running, but you only have so many ports. So the alternative, if I want to run another thing on the same thing, is suddenly I can have it. I can do this and assign. Sorry, did that backwards. And assign port 81 to port 80 in there. So I can do that. And I bet you if I go over here, do this :81. Bam, we're now online. But of course, that's crazy because you can't tell your users to go to different ports. And there are all sorts of ways that people are trying to come up with to try and make it easier to not have predictable, well-known ports. But that's a real frustration. And so I'm jumping ahead to a question that you haven't asked, but with what Docker is, how can we take it to the cloud? Did I jump too far ahead?
No, I think, hey, you've got a flow. Let's go with it, man.
Awesome. So, but I bet within this group, a lot of people have suffered some of the frustrations with that problem. And a common answer is to be able to. I was bringing up the chat, but now you can see it. A common answer is actually just to front everything with a load balancer, but what that means is that now you have the load balancer, which is another step for things that can fail. And so if we want to get rid of the load balancer, what we have to do is figure out a way so that every container has its own identity on the network, and that's a really useful thing. But there's another problem here, which is no matter how many instances of this that I run, and by the way, this syntax will change it so that it'll give me a random IP address. No matter how many instances of Nginx I run, I still only have so much CPU, so much RAM. Now these instances aren't doing much of anything, but and so this thing is mostly unloaded right now. But what you can see clearly is that having more containers on the same VM doesn't get you more performance in a lot of cases. If what you're doing is constrained by memory or constrained by CPU, adding more containers doesn't really help. And so that's another frustration about going to the cloud. But there are that doesn't mean that it doesn't work. Yeah, that's there. I'm totally jumping into the whole Docker thing. I think you know some questions that I should be getting into, and I should take a break and make sure I ask that.
So, all right. So we have, I think, and folks, again, if you have uncertainty about what Casey's just talked about, you know, throw questions into the chat, and I'm happy to pass them along, or I think he can see the chat as well. Okay, so we've got Docker, and we're able to launch Docker instances, and like you were saying, now we start getting other pieces, and one of the other pieces that typically, if you're running on more than a single node, you're dealing with is some sort of scheduler. And so Docker has its native Docker Swarm. Previous sessions we've gotten into Kubernetes, which is another very popular schedule. There's also kind of the Mesos Marathon approach. And I think one of the issues that you have is that each one of those schedulers dealing with where to put multiple instances starts to get a little bit complicated. So I think the point of the way that Casey is approaching how a container interacts with a scheduler is pretty unique. So maybe you could tell us a little bit about what you think a scheduler should do and what you think a scheduler shouldn't do.
Indeed. Yeah, that's a really great start to the question, because you know, there's an interesting set of concerns necessary to run run containers across multiple hosts. Obviously, there's the point you made about having to run with schedule those things to multiple hosts, but there's also that concern about how do you get things configured so that when they are running, they're doing the right stuff, and so that process of what we often call orchestration, that process of automating how we configure our applications so that when they run the right way. And what I was just demonstrating earlier inside of VM, you know, we used to talk about cowboy coding and wearing silly hats when we have to do something on the server, but in so many cases, a lot of operations are dependent on people doing stuff on a server to either unlock the credentials for something or set the right place to point it to. And we've worked on ways to sort of automate that using Puppet or Chef or things like that to help with those things. But it still seems to be a problem that comes back. And as we Dockerize things, what we get to is this increasing need to really truly automate everything. And so when we do that, we get to we get to this need to not only do we have to automate everything, but it has to be automated really, really quickly. So let me share screen again. Go back to this one. And I'm going to start with, so actually one of the things you mentioned earlier was actually Docker Compose, which is a way to run a bunch of things all at once. And so what I've got here is actually this Compose file. So I just started Docker Compose over there. I'm going to bring up the Compose file here. And you know what? I'm going to bring it up on the web. That'll be easier. So bringing up a Compose file here from GitHub, that's the best place to look sometimes. Maybe I'm biased. And examples, and go in here and Docker Compose. And so this Compose file, a lot of different scheduling solutions that allow you to run multiple containers, they give you a way to create what I call a manifest that allows you to describe the different things that you're running. And so in this case, what we've got is, somehow ended up on Nginx, forgive me. I meant to go to MySQL. So right now I'm looking at this compose file to run MySQL. And it's got actually these two different pieces in it, but they're defined in Docker Compose as services. And so one service I've called MySQL, and another service is called console. And we'll definitely get into what console does to help coordinate some of the operations here. But I bet a lot of folks in this room, in this conversation, are familiar with it already. But by defining this as a service, the cool thing is, now that I've started it, I've done the Docker Compose up -d, so everything is started. Those two different things are started. What I can do now is I can scale it. So let me just scale that. And what I'm doing here is I'm scaling MySQL, that thing that we defined in here. So every time I go to start MySQL or scale it, what it's doing is it's using the definition of how it should run here. Let me make that a little bigger. Hopefully that comes through cleanly. Making that, just repeating the instructions of the definition that's here, and it basically just turns it into a bunch of Docker run. And so if you're using Docker on your laptop, if you're using Docker Swarm, as you mentioned earlier, what happens is this actually just works. And it works, again, on your laptop or in the cloud if you have Docker Swarm. Now, I didn't go through the process of setting up Docker Swarm here. I'm gonna admit right away and sort of give something away, but we're gonna get into how that works. The cool thing is that we're able to scale this right now, and it's actually scaling in such a way that this is running multiple different, multiple MySQL instances, but each one of them is getting an additional CPU and resources to run. And so we're starting MySQL there. And the cool thing is, the way this is working is that that MySQL is actually set up, let me go back here to GitHub, in such a way that the orchestration of MySQL is set up so that the first instance of MySQL up actually becomes a primary, and subsequent instances actually become replicas of MySQL. And all of that is happening because what we've done is we've automated some of the activity as MySQL starts. This isn't activity about what Docker does or what Docker Compose does. It's actually just automating some of what MySQL does as it starts and as it comes online. And so the things that it does is it bootstraps and comes online, it looks around to find these things. And I want to spend time talking about that, but before I do, I want to show you how this can work. And so let me prove to you that this is working. Does that sound fair?
Let's go for it.
Here's what I'm going to do. I'm going to use Docker exec. And so Docker exec is just a way for me to run a command that's going to execute in the named container. And so here, Docker exec -it means I want to attach it and do it interactively. And then I've got the name of the container that I want to work with. And so that matches MySQL 1 there. And then this is the command. Everything that follows that is the command. And so anybody who's familiar with MySQL is probably familiar with this syntax, certainly, and has probably used commands like this exact command to check this out. Now, understand, you are now looking at my password for this database because I set it to something really insecure. And you can laugh at me later, but these instances are not going to laugh. I would never, by the way, suggest using such insecure passwords. That said, I'm sure people do it all the time. But what we can see here is that we've got the information about, and I hate the antiquated terminology, but we've got the information about what replicas of this host there are. Now, let me show you. So I'm going to do Docker PS, and let's just take a look. Now, the trick is Docker PS. You have to have a screen a mile wide for everything to fit. But Docker Compose PS will give you much prettier output. We'll be able to see this. Even better, we'll be able to see how each of the different services work. It'll be sorted by the different services. So you saw console in the description. We are going to talk about what that does, but here are the 3 instances of MySQL. And what I showed you earlier was all 3 of those instances are connected to each other. MySQL 1 is the primary, and MySQL 2 and 3 are the replicas. So let me go here and run this command. And what you can see here is that replica is all attached. So let me pause for a moment and make sure that we understand. We've got MySQL running in Docker containers, and what you just saw me do, all of the commands that I've just run were Docker Compose up. Let's just let's go through some of them. Docker Compose up, then Docker Compose scale. Then we went and took a look at what it was doing. And so just those commands gave us a 3-node cluster of MySQL. Well, sorry, not a true cluster, a primary and 2 replicas. And we've got all of that running in Docker in the cloud with just those few commands. But we haven't really done any work with that. I'm surprised you haven't called me on that one yet.
Sorry, jumping between chat and stuff.
No, that's fair. So let me bring in some data here. Again, what you can see is the command doing a Docker exec, and I'm running this command on the primary again. And this time, I'm typing, doing this bash -c because when you want to run using Docker exec a command that has a lot of redirections, piping in it, as this command does, it can be hard to make that work and interact with Docker exec. So bash -c is a secret. You certainly, this is not the first place or last place you'll hear it, but just keep it in mind as you're trying to do complex shell stuff. You can do that. And so what I'm doing is I'm downloading. I think people will recognize that I'm downloading a file full of a dictionary file. Honestly, not a password dictionary, not that. And I'm injecting, I'm getting that into the database instances. So that the content of that database is now, well, we've got a little less than 500,000 different words in there. And you know what? Let's go off script. So we're just going to go and get an interactive command line in here. And I'm going to do something like, and we're going to, let's see, select, actually, we're going to do, yeah. So we're just going to select 500 of those. And you can see there's quite a silly set of words in here, all conveniently alphabetically sorted. But I'm going to get out of that. So Control D to clear out of that. And let's make sure, because I did promise that this MySQL running in Docker in the cloud was running in a proper primary and replicas. So what I just did was the same query that we did a few steps earlier, but this time I'm executing against MySQL 2, which is one of the replicas. So the same query, making sure that we have the exact same number of results. So let me put both of those on screen, actually, is what I should have done. So we know that the replication is working. We know that all of that stuff is going on. And what this demonstrates is how we can use solutions that are sort of naive, the way Docker is. We're not using anything special. We're really just using Docker, things that you can do in pretty vanilla Docker, with Docker Compose to define this. And we set this up so that it's actually all fully orchestrated for a sort of complex application. Are there many MySQL users in this group?
Doesn't everybody use MySQL? I think it's interesting that, I mean, often the two complaints you hear about using containers over VMs are, you know, security concerns versus VMs, you know, the abilities that VMs have to provide security, and also the fact that you running a stateful application like a database really isn't a cool thing to do. So it's interesting that you're actually using a database as an example here.
Yeah. Yeah, I mean, it's something that I've definitely gotten a lot of feedback from people that they love Docker, but it's not for persistent applications. It's not for anything like that. And the challenge is typically how do you get everything to wire up? How do you orchestrate everything? And that's part of the fun of what we're doing here, because as we dig into how that works, I think we'll see that it's actually kind of easy. I haven't really orchestrated this application, however, if I can't do the following. If this application cannot survive losing its primary, then we're sort of at a loss. So here's what I want to do. We're actually, remember, MySQL 1 is the primary, and so we're gonna do that. And as that falls over, I want to go over here. And I want to take a look. So this is a dashboard, and I'm in doing this, I'm sort of showing, sort of revealing my hand in a way. That as I refresh this, it's going to tell me that MySQL 1 doesn't exist anymore. And that's exactly what we see in the command line on the left. The cool thing is, however, that, so we've got just 3 things running, but it starts with MySQL 2 and MySQL 3. The cool thing, however, is we still have all of this working, and if I check on MySQL 2, what the replication status is, what we see is that it still has a running replica. We're down to 2 instances, and if we check on MySQL 3, what we'll see is that it's actually connected to MySQL 1. So master host is 108. There's quite a bit of microphone noise from one of them.
I was just looking. It looks like everybody's muted. Wait. I think we got it. Okay, carry on. Sorry about that.
So if we look at this, what we'll find is that this is the IP address for MySQL 2. And so what happened was when I stopped that primary, we've actually automated the entire process, again, within just plain vanilla Docker, of electing a new primary from among the replicas. So right now, we only have 2 instances of MySQL running. And I'm going back to, I should have just typed it in. We're going to get Docker PS on this, Docker Compose PS. We see that we only have these 2 instances running, but one of them is the primary. And if we have applications working on those, they're actually still going to continue to run just fine. And the cool thing is, I'm now going to make that, bring that back to 3. So I'm going to add another instance, and what we'll do is here is start MySQL 4. And that will get us to the point where we again have 3 running instances, and never did we lose any data. In fact, I can show you that. Bring that back. Do that in another window where that happens. We'll get our data there. And then when we get MySQL 4 up and running in a moment, we'll see that that new replica starts with all of that data. Yeah. So I definitely want to dig into how that works. Are there questions that we should talk about at this point?
So we had a couple of folks just saying that they're not using MySQL, and I just in the chat was saying that the point of this exercise isn't that Docker is great for using MySQL. It's more showing you what Docker can do in terms of managing an application and dealing with multiple instances of an application running in the container. So if you're losing stuff, it's not a big deal.
Exactly. This isn't so much about MySQL as it is about how do we run applications in an automated way. And that's why I want to dig into how we've implemented this. So yeah, but it's a really great question because you know, we sort of joked earlier about this, but it's not what I mean. You know, the point is definitely not MySQL.
Right. So this is cool. We've got you see how one piece of the puzzle works and is managed. So we have sort of a baseline, but I think people are probably thinking, all right, well, you're not just going to run MySQL. You're going to have, especially if you're looking at something that's a microservices architecture, how do you fit the pieces together? Which is hopefully where you're going next.
Yeah, exactly. And so what I want to bring up some slides, but that is going. I'm getting the beach ball on that. So.
Oh no.
No, that would be horrible. So yeah,
well, Casey, yep. if you wanted to, I mean, we haven't gotten, and we're going to get into it later. That's fine. But there was a question asking about Kubernetes, and we're maybe ahead of talking about scheduling, and if this isn't the time, awesome. If we're waiting for the beach ball and you want to put it.
No, that's an awesome question, and the reason I'm actually demonstrating this not using Kubernetes, because you can do all of this stuff in Kubernetes, and you can actually do it 2 different ways in Kubernetes. It's worth considering. The reason I'm demonstrating this not using Kubernetes is actually to demonstrate that the concerns of orchestration are actually separate from the current concerns of cluster management and scheduling. And the reason I'm interested in making that point is that when we mix those 2 things, what we end up actually doing is attaching all of our orchestration to the scheduler in a way that can make it hard even to upgrade your scheduler. So let's say you end up getting a mission critical application that is dependent on something in the scheduler, but then the scheduler changes and you have, the scheduler API changes in such a way. And now your mission critical application requires that you run an older version of the scheduler. Or let's say you have 2 different companies that have chosen different schedulers or different teams within the same company. is it possible for you to use the same orchestration code if it's attached to the scheduler within those two different teams, or do they actually have to duplicate the same work oftentimes? With simple applications, this isn't a problem. But as we look at really complex applications, it can become a serious problem. And so that's why I separate them, because the patterns that I'm demonstrating here actually work pretty much anywhere. In fact, let me, I think this is a perfect time to bring it up. Let's see, are we looking at some slides? Is that now, are those now on screen?
Looks like the slides are happy, yes.
Perfect, perfect. And so the thing that I'm demonstrating here really is about how when the scheduler starts the container, that's a really important signal to the container. And actually, you can do this with a virtual machine as well. The crazy thing is, you can make an auto-scaling group in AWS. And keep in mind, AWS is a competitor to my company. But you can make an auto-scaling group in AWS. And you can actually do exactly what I just demonstrated. Now, keep in mind, in an auto-scaling group, you don't, and you can do this with VMs, I mean. And so it's basically the scheduler starts the workload. And it's really important to keep in mind that the AWS API, EC2 API, that's a scheduler. It's just a scheduler that you interact with and think about in a different way. And when you create an auto-scaling group, what you're doing is adding supervision to that scheduler, so that if we lose a container, what it'll do is it'll start, or sorry, a VM, it'll start a new VM. So the Docker image, if I had shipped that as an AMI, it would behave exactly the same way. If I take that Docker image and run it in Kubernetes, it'll behave exactly the same way, because it's depending on this one thing that every scheduler does. Sorry, well, two sides of the same thing. That is, it starts things and it stops them. And yeah, you can tell me about how it'll figure out where to run them and all that stuff. But the most important, the absolutely most important thing that the scheduler does is it stops and starts them. And so with that in mind, when MySQL starts, when MySQL starts, the first thing that we need to do is think about how what has to happen. And so hopefully you're seeing the new slide. And so the first thing that this implementation of MySQL does is it actually looks around for an existing MySQL cluster. And if it finds one, that's great. But if it doesn't find one, what it does is sets up as the primary. And so if it doesn't find an existing cluster, it sets itself up as the primary. And then it starts backing itself up. And it registers itself in the service catalog. That's console. And that's where we keep a record of all the running components of the application are. And then as the scheduler stops it, which is exactly what happened when I stopped that primary, notice how the first thing we do is actually deregister from the service catalog, and then we stop MySQL. And the reason for that is, by deregistering from the service catalog, we can actually insert a delay. We could actually make it even smarter than it is right now and wait for running queries to exit. And so we have this time from the graceful stop to when we're going to force it to stop, and that's actually configurable in Docker, which is fantastic. You can actually configure it to be infinite. And so you have this time to let things drain, which allows you to get some really great high availability scenarios in this story. But if we're not talking about the primary, if what we're doing is the replica, the first thing that happens is when the scheduler starts that workload, when we find an existing MySQL cluster, the thing we do, and the thing actually, now I realize I want to make sure that we do here. There we go. I want to go back here, and we have that is started. So let's run this query on MySQL 4, and we'll see, bam, it has so it started up, and it has bootstrapped with all of that same content. And the reason that that works is that the first thing that happens is that it will looks for that cluster, it joins that cluster, and it bootstraps as a complete replica in that cluster. And that's how we're able to do this, by just hooking different events to the start and stop of the application. And the amazing thing is, you might think that that takes a lot of code. I'm going off script, and I'm going to do this again. Hey, actually, when my display does the beach ball, do you all get to see that as well?
I'm just seeing a black screen right now.
Alrighty. Well, so what all of that takes is about 400 lines of Python. And I mean 400 lines of really thoroughly commented Python, so that there's all sorts of room to explain exactly how that works. So let me get that on screen here in a moment. Zoom and the slides don't like each other, is what was going on there with the with that. But let me share that screen. Yeah. So here I'm going to go back to GitHub, go into bin, and what you'll see is manage.py. And this is the entirety of it. So 408 lines, as you can see, bam, 407 lines. And what you'll see in here is, when I say really well commented, long multi-line comments explaining all of it. So all of that automation, and if you were to compare all of everything that we've done, honestly, with RDS, you get basically a point-for-point feature set that gives you that identicality. And so all of that comes together in a way to give you that sort of automation. And not only does it work, to demonstrate what we did, and by the way, I call this the Autopilot Pattern for what kind of things that we're doing, because we're building applications that honestly work like they're on autopilot. And so I call it the Autopilot Pattern. And as you saw, everything there in MySQL is in GitHub. It's totally open source, and it does the job. The cooler thing, however, is that it actually works across different environments. So what I demonstrated running just in plain Docker runs also in Kubernetes. You had to have different manifest files for Kubernetes, but it's the same Docker image and all of that. So yeah. I think there was a mention of Mesos earlier, and so it even runs in Mesos and Marathon without any modification. So, yeah.
That's pretty cool. You hit all the big ones for sure.
Yeah. Now the cool thing, and I'm gonna go away from the slides here, because that's well, I like going without script, honestly. Now I want to show you something cool about how this is running, because the truth is, it's the way we're running it is not actually in plain vanilla Docker. It would work the same way in plain vanilla Docker, or a similar way, but here we go. I want to go back here and show you. We're actually running it on Triton, which presents to the user, me, you, anybody, presents to the user what looks like a Docker API endpoint. So I'm going to do, let's see, env grep Docker. So I've got my environment set up here, actually, to talk to a Docker API endpoint. And what I mean by that is, of course, Docker running on my laptop is connected to Docker running in another data center. But in this case, That data center is our cloud, and this API endpoint actually speaks to the entire cloud. So when I do, and those Docker instances run on bare metal. So what I'm going to do is Triton instance, a list of all the instances here, and the answer we'll get back will include similar answer to what we saw with Docker PS. And so the same instances that we saw in Docker PS are running here when I do Triton instances. Now it's worth knowing, Triton supports not just Docker, but I'm going to talk pretty much only about Docker here. But I also want to do something. So we've got that list of 4 different instances. What I want to do is Triton. Now I got to remember compute node. Name. So I think that's the right syntax, if I remember correctly, to get the name of the compute node, sorry, the ID of the compute node as well as the instance name. And if you look carefully, what you'll see is that each of these is running on a different compute node, but let me just prove that to you here. So change that, sort, unique minus C. And there we go. So what this will do is get just the IDs of each thing, and you can see that each of those 4 different containers is actually running on a different physical compute node. And we didn't have to do anything. We didn't have to set up any swarms or anything. We just did that, and it worked easily. And so that is the great thing here, is that the things that we can do with Docker Swarm and Docker Compose, we can actually just bring to Triton, and they just work. Yeah.
Very cool.
So I bet you there are quite a number of questions about that. I haven't been looking at.
Well, people have been a little bit shy for no good reason. Guys, we are here for you, both Casey and myself. So, I mean, this is some really cool stuff. It's my experience has been much more on the Kubernetes side, and this is a very interesting and different way to look at how you put an application and manage an application together. And, you know, by all means, if you're shy to unmute and speak, feel free to throw stuff into the chat. And I'm sure Casey would be happy to take any questions. And it doesn't necessarily need to be about the autopilot. If you're unsure about something he was saying with how Docker works or Swarm or the relation to Kubernetes, all of that stuff really is fair game.
Yeah. So I'm going to do, let's see. I've got, so earlier I had started Nginx on Triton, and so I'm going to do Docker Triton inst. And so I've got an Nginx instance, which is here, and we're now getting some details about it. And so we can see that it's running. I'm going to do a Docker exec it dash, and I'm going to go inside and show something else that's kind of different. So let me clear this. And the cool thing here is that we've got a few different Ethernet interfaces on this. The cool thing here is that the E1, if we go to this IP and this container that I just barely started, we're actually getting directly to that container. And one of the differences between the way we've implemented Docker, because we run these things on bare metal and we use features of our cloud that were built to run containers on bare metal for a long time, we give every container, Docker image running in a container on our cloud, we give every container its own network interfaces, and because I asked for it, because I exposed this particular container to the public internet, it gave me this ETH1 with a public IP address. And the cool thing is, I never will get a conflict on that IP address because this is its own IP address just for that container. So I can have as many different things running on that container as I want, and I never have to worry about what different things might be running on that IP. Yeah. So let me take a look at the chat. Thank you, John, for explaining that was Ren and Stimpy. It's one of my favorites.
Yeah, it's a classic, absolutely.
Yeah. You know, it's the I used to use it every time every time it was time to launch something big, you know, something dangerous. Anyway, yeah.
Excellent. So one thing that was interesting, and I may have missed it because I've kind of been jumping between things here, that was that from your DockerCon talk, you were talking about how with this autopilot approach, you're actually able to let the applications within the containers can actually figure out where they have to find connections rather than sort of having a scheduler
Absolutely.
or some other system kind of assign it to them, which I thought was an interesting and different way that this process that you're demonstrating works.
Absolutely. And you know what? You make a point, because I haven't really gone into how I do all that. And the trick there is that I use we built something. We couldn't find anything that did exactly what we needed to do. That is, simply handle this process of starting things, taking care of what needs to be done when the container starts, and what needs to happen when the container stops. And so we built something. I think a lot of the people in this conversation have probably spent time building bash scripts or something else to do this sort of thing. What we found was that we were doing that, and there were a lot of similarities, and so we were like, well, do we build a library? Do we start using the same thing? And the answer is yes, but let's probably not do it in bash. So we built this little tiny application. It's written in Go, and let me scroll down to the README. And what it does is it runs in the container with everything, and it handles this problem of how do you know. It is the work of registering things with the service discovery layer, unregistering them, and then when things change, modifying that. So triggering those different events. I'm tempted to go back to this slide, which I'm not going to put in presentation mode just to save time, hopefully. Well, it did not save time.
Right.
And so
that's pretty good.
Yeah. And so one of the things I want to point out here is this 0.3, when we're running a replica, the thing that it's doing is watching for any changes in the primary. And let me show you where we're watching for that. Let's see. So we're using a discovery catalog called Console. Console has a really great understanding of services, separate from separate from just a key value store. It actually understands services. And so what I've done, and you would never run with console exposed to the public, what I've done here is that I brought up the web UI for this, and we can see the different services that are defined here. And so we've got what happened, and we're, when I stopped the primary, is that instance is still recorded because I stopped it uncleanly. If I was doing an upgrade, it would remove from here cleanly. But that service catalog has this knowledge of multiple primaries now, which you would never have in practice. You could never have multiple active primaries, but it remembers that dead primary that is there. And so we can see it. At some point, it'll clean up. But if we get an alarm in the middle of the night and all of this stuff happens automatically, the cool thing is we still have this log of what happened, and it'll clean up in time. And then it also has these different MySQL replica instances recorded in there. And so the big task that Container Pilot does is to register things automatically and watch for changes in here, so that as that primary changed, as this primary changed, what happened was that's the event that triggered, as this went unhealthy, that's the event that triggered all of the replicas to elect a new primary. And that process of election is defined in the application itself. You know, earlier when I asked the question about who's mostly focused on operations versus who's mostly focused on development, a big part of that question was trying to figure out how much of a wall existed for people, because the real question, and I'm using MySQL as an example here, which is not necessarily the best example for this question, but if we're building an application that has some state to it, who better to help manage that state and manage the operations, those complex operations, honestly, than the developers who are aware of how that's going to behave. And so by implementing things this way, what we actually do is we can involve developers in defining the operational behaviors that need to happen at various points in this application's lifecycle. So imagine specifically, and I didn't demonstrate this, but we can. I can do a rolling upgrade of MySQL to deploy new versions, and we won't have any downtime whatsoever. And that's because of the automation that we're doing here. And so there's actually a question about this assumption of a load balancer in front of that. And the trick about this is that there isn't. Load balancers are obviously points of failure, but they're also points of slowness. And so what we're doing is we're automating the discovery. Instead of centralizing discovery in load balancers in front of those services, we're actually automating the discovery such that it can be moved into those applications, and they can direct connect to each of those things for much better performance. Even better than that, much better failure handling. Because you never know if you're talking through a load balancer and you don't, and your connection hangs. Should you retry that same load balancer? Should you move on to another? What should you do? And as a developer, we honestly have there's a lot. Having that load balancer in between creates a lot of confusion about how to handle those errors. So yeah. I also saw that there's a question about external IPs, and for MySQL, to be clear, MySQL is not running with external IPs, or I would never recommend it. But each instance of MySQL has its own IP on the internal network.
Well, cool. Hey, I think we're coming up on time, so unless folks have additional questions, I mean, this is one of these topics where I think you could just keep unpacking and unpacking. So maybe we'll have Casey come back and do a reprise at some point. But yeah, I don't want to cut you off if you had anything else, but I think we're probably
No, John, I really want to thank you for having me, and thank this audience for being a great audience. And I'd love to join the conversation again. This has been fantastic. Thank you.
Yeah, no, it's awesome, and we definitely have some other venues where that's a little bit more operations focused, where I think this would again be an interesting discussion. It's a very interesting approach to managing containers and scheduling them. So thanks again for presenting to us. Thanks everybody for joining. I will be posting. Casey has a nice DockerCon presentation that I think runs through the process maybe a little bit more orderly than we did in this particular presentation, which might be helpful if you want a second view of it. This was recorded. We will be posting it up on our YouTube channel. So if you haven't, I will post a link to the channel. I will also post a link when I actually get it up on that channel. But if you subscribe to the YouTube channel, whenever we post something new, you get a notification, so you don't have to keep going back and looking to see if we posted a link. You'll get a notification. And yeah, with that, again, thank you so much, Casey. Thanks everybody who attended. Awesome, good fun, and we'll see you at the next one.
Thank you.
All right.